Joining us now here in the studio, Matt Leevy, a professor of biological sciences at Notre Dame's College of Science, where he directs the In Vivo, that's I-N-V-I-V-O, In Vivo imaging facility. Matt, welcome to Notre Dame Day. Thanks for being here today.
It's a pleasure. It's a pleasure.
First of all, tell us what is In Vivo?
So in vivo imaging refers to the use of state-of-the-art technology to non-invasively detect different diseases or biological processes within living specimens.
So the idea is you're looking into living things, right? So would like an MRI or a PET scan or a CAT scan, I mean, are those examples of in vivo?
Exactly right, exactly right. So within the clinic, that living specimen would be a human patient, and we would use things like MR, a CAT scan, or a PET scan to look inside for diagnosis. And on the preclinical side, those living specimens are mice and rats, and the technology is a bit smaller, but it's much the same concept, and we can peer inside. And since mice and rats have the same sort of diseases that humans do, obesity, cancer, diabetes, we can use the same technology to look at the same models of disease.
Sure. Is there a reason that, or is there a specific goal that you're trying to achieve, that is make the imaging better, clearer, sharper? What's the advances that you're looking for right now in that kind of imaging?
So a great question. There's sort of two answers to that. Number one, we are using this equipment as a tool to better advance our understanding of the diseases that are going on.
And we're seeing some examples right now. So what are we seeing here?
So this is a classic example. This is our first big result where we were actually doing non-invasive, or excuse me, in vitro imaging, looking at bacteria spreading across a petri dish.
Oh, okay.
So that is sort of a real-time image there.
It was kind of blooming there, huh? So
Indeed.
So when you do those samples, I think we're all familiar with that. You might take a sample, put it in a petri dish, and you allow things to grow. And so this is one way of just sort of imaging that to see. And,
Sure.
and what does it pick up on? The actual tissue of the living cells? What does it see?
Right. So in that particular case, what we were looking at is just the growth and the dynamics of that growth across a petri dish, and that simulates the surface of any type of surface on which bacteria might grow.
Right.
And the idea being, the broader idea being, we do our best to try to be clever and interface this technology with different research that's going on campus.
So if you were to look inside my brain, God forbid, and see nothing, apparently, you see different kinds of things. Are you working then with like companies or I mean, there's got to be a huge market for this, I would think, out there of people who need and want this kind of imaging.
Sure. So we're working with groups all across campus to help bolster their research programs. We're working with several companies off campus for research to boost the imaging technology and to boost actually some of the safety around that imaging technology as well.
And other institutions as well, working collaboratively?
Absolutely. So we have ongoing collaborations with Mizzou, WashU, MD Anderson, just to name a few off the top of my head.
All right. Well, Matt, thanks for joining us today. Interesting stuff. I wish I understood any of it.
Too easy. Thank you so much.
Maybe someday I'll learn.